be recorded, and you will, of course, receive a follow-up email with a link to the recording and some additional collateral. So the question is, do you find SQL and IBMI to be one of its superpowers, while at the same time being challenged by the JDBC and ODBC jobs that hit your system with poorly written SQL statements, massive file joins, and requests that multiply before your eyes? These can bring your IBMI system to its processor and storage knees and leave your end users twiddling their thumbs and the resulting nastygrams, of course, in your inbox. So today, we'll be talking about both sides of the coin, what you can do when these requests hit you hard, and how you can exploit SQL to better manage your system. My name is Chuck Lisinski, and I am the Director of Technical Solutions at Help Systems here in Minnesota, and joined today by my colleague in Peterborough in the UK, Ash Giddings. Good morning.
Good morning, Chuck. How are you?
I'm good. I'm good. Of course, you're 6 hours ahead of us.
We are 6 hours ahead of you, yes. It is just gone 3 in the afternoon here in the UK.
Now, I'm quite involved with our local user group, QUser, and Ash, you're involved with Common Europe.
Yes, indeed. Yeah, I have been for maybe 6 years now. So yeah, Common Europe, we get to meet and to greet IBM, normally face-to-face, a couple of times a year, normally tagged on to the end of user group meetings somewhere in Europe. But yeah, so we have a valuable insight into the fantastic IBMI platform and its future. It's a great group.
Awesome. All right, let's talk about the agenda.
Fantastic. So in many organizations, IBMI has quickly become the hub or the focal point of the business, because in lots of cases, it's running core applications. It's also probably the most stable and versatile platform you run, and as a result, is home to a number of databases. The methods of accessing this data continue to grow, making IBMI a vital cog. So today we're going to explore what these methods of data access are and what they are like for us sysadmins tasked with monitoring them, identifying them, controlling them. We'll then take a look at IBM's fantastic DB2 for I services before leaving some time for Q&A. So if you have any questions, please use the question feature in GoToWebinar, and we'll get round to as many as we can. So we're going to launch the first of 2 poll questions. Let me launch this. So we'll do this before we get started. So this is the first poll question. How in your environment do you detect and manage any offending SQL requests? Now you can multi-select these. So does the machine get slow? Do you notice a visible slowdown? Is that how you first notice it? Or do you go old school and use the work act job and F16 on the CPU column, or work sysact or something like that? Or maybe the users call and complain. Users are not shy in telling you that there's a problem. Or maybe you don't know who or where these requests came from. They can be varied, SQL requests, so maybe you're struggling with that. Or maybe your data guys aren't much help. So we'll just leave that open for a few more seconds, and then I'll share the results.
Yeah, Ash, you hit the nail on the head. I spoke with a large food distribution company over the past week or so, and they use DB2 on IBMI as their backend database, and they have their customer interface hosted by AWS, and they've got a nice web page up there, and they're pulling and pushing data back to DB2.
Wow. So here's the results. Myself and Chuck were talking about this just a couple of days ago. I think still most people, they'd use work at job. It's the quickest, it's what they've always done. but is it the most effective? System gets slow. Yeah, the first thing you do, you think this is a bit sluggish, a bit laggy, wonder what's happening. And of course, as I say, users are never shy to complain. They're used to these machines being ultra fast now, and any dip at all, they're quickly on the phone to you. So thank you very much for filling those in. Chuck, any more observations there?
Those users are so demanding.
Life would be so easy without them, wouldn't it?
Exactly. Well, let's talk about the remote database connections, because we're seeing more and more of this, quite an uptick of using DB2 as the background database to support various websites and other services for your end users. And oftentimes what we'll see is, of course, an incoming payload with that SQL or that JDBC or ODBC request hitting your system, requesting data, potentially doing file joins or whatnot. So anyway, identifying the jobs, of course, is job one. QZDASOINIT and QZDASSINIT for secure connections will identify those incoming ODBC and JDBC connections. Likewise, DDM type connections are the QRWT server jobs. Those are pre-start jobs. So of course you'll see those in your subsystem. Typically queues are work by default. And likewise QSQS jobs. Now the subsystem that those jobs show up in are predefined, but they can be manipulated. All right, there is a way through SQL where you can route those requests, and I've actually got a link that I will send out to everyone in the chat that will show you how to route those requests to specific subsystems, thereby helping you better identify those workloads. So the challenge that we all run into is identifying the workload, identifying what's happening in that workload, and putting thresholds around that. Where is, at what point do you take action, and what sort of action can you take? We've seen through the survey that a lot of it tends to be manual. So there is a better way, and that's what we want to talk about today. I want to talk about real-time proactive monitoring for ODBC, JDBC, and SQL type requests. All right. And so what we're going to do is we're going to talk a little bit about Robot Monitor. Robot Monitor is a native system application and performance monitoring tool for IBM I that has also been leveraged out for AIX, VIOS, and Linux. So not only is it IBM I, but it also reaches out to other operating systems as well, but IBM I is still the hub. This tool has been in service, so to speak, out there in industry for a couple of decades now, but we recently brought it into the robot product line. We brought in a dashboard interface and have made several enhancements around SQL monitoring specifically. The beauty of this tool is it can be customized specifically for monitoring certain workloads. So think about QZDASOINIT, QZDASSINIT, QSQS, and so forth. You can focus that monitoring on just those workloads to get real-time monitoring and historical reporting, along with a lot of other monitoring, including, for instance, monitoring mimics, BRMS, Robot HA, Power HA, MQ, and so forth. And if you're in a multi-partition environment, this is especially important. As mentioned, highly customizable if you want to see real-time or short-term information, or maybe information over a longer period of time. That is the beauty of this tool. The architecture looks like this. Robot Monitor needs an IBM I partition as its central monitoring hub, and that's the central database. So of course we're using DB2 as our database for storing the collected information. On each of your partitions, IBM I, VIOS, AIX, or Linux, data is collected, it's sent up to the central Robot Monitor partition, and from there the robot monitor graphical interface is used for visualizing the information and for setting up things like thresholds and for doing external notification. Several ways to do external notification. We'll talk about that and show you, but we have a direct interface to Robot Alert to send information out to the outside world. Now, with respect to QZDASOINIT or those incoming JDBC or ODBC requests, what would you monitor? Well, straightforward monitoring would be, for instance, something around CPU usage, disk IO, faulting, job count, QTemp size, temporary storage, and so forth. So what you see in front of you is a pretty complete list of the IBMI metrics that we can collect automatically through Robot Monitor. For configuring monitoring of these incoming requests, it's simply a matter of choosing the monitor type that you want, the job that you want to monitor. If you don't want to monitor by job name, you could monitor by username, current user. You could include subsystem, and the more information that you include in the definition, the more specific you'll get with your monitoring. For any monitor, you can set up thresholds. We have some predefined thresholds, but this is really the beauty. So behind the scenes, we're going to be looking at this specific workload on IBMI, and we're going to send out notification either through Robot Alert or maybe a message in a message queue that you can monitor with a message monitoring tool. So you can be notified proactively before that end user calls you to say, hey, we've got issues. Notification via multiple methods, as mentioned, maybe just a message in a message queue to get the word out. So for instance, if you receive a text message from a robot monitor saying that your JDBC CPU utilization is high, you can easily drill into the graphical interface and see exactly what jobs are consuming CPU for your JDBC connections. And likewise, you can drill directly into those jobs and see the SQL statement, the IP address. You can even take action on the job. All right, so let's go live for a second and let's take a look at some of this. So I'm running along and you know, I might get a complaint. Ash is now dialing me up or sending me an email saying, you know, we've got issues. So I might start with a work system status command. All right, and I can see CPU is you know, pretty much normal, and all of a sudden we get a bump. All right, so what do we typically do? As mentioned, we do something like a work active job. We sort by CPU, and we can see we've got a job here hammering the system. Working with the job, we don't have a lot of options. All right, we don't know, for instance, what the SQL request behind the scenes is, so typically we'll just end the job. All right, and life is good. All right. So this is the robot monitor interface. All right, this is the dashboard showing you 3 partitions that are of interest. So at the current moment, we're looking at IBMI partitions. All right, and we can see the system that we were just on, the CPU, overall CPU utilization was high. All right, we can see our disk storage across 3 partitions, uptime. We can also see our JDBC CPU utilization and so forth. So this is highly customizable to whatever your needs are. And likewise, if you do have thresholds set, you can see we've got a number of thresholds that have been triggered here. Now, we just had a JDBC connection that triggered a threshold, so we got some alert notification. Okay, so proactively behind the scenes, we were looking at that activity. All right, so let's take a look at a live JDBC connection that's going to execute a whole bunch of SQL. Basically what we're going to do is we're going to generate a table. We're going to insert 8 million rows a couple of times. And you're going to see this live now. So we're running this through ACS, Access Client Solutions, and we're doing a run SQL script. And that's going back to my IBM system called Wisdom. All right, so that's listed right here on my dashboard. All right, so what we'll see is we'll see our secure JDBC connection increase because I am using a secure connection. All right, we'll be able to drill into that activity directly from the graphical interface. Now, this is monitoring real time, meaning every 30 seconds, we're out there collecting data from the activity on your system. All right, so it will take about 30 seconds. You can see now, all right, so we've got some activity. So at this point, I'm being notified via email that CPU has increased. All right, we're going to see that represented here in our SS connection as well. Because that's my Wisdom system, all right, I can start drilling into this right now. And in fact, I've created a separate dashboard group just for my JDBC activity. All right, so I'm looking at JDBC CPU, looking at the number of JDBC connections. I'm looking at secure JDBC, number of secure JDBC connections, JDBC runtime, etc. And so what I can do is just right click and say show details. All right. And from here, I can right click, work with job, and drill directly into the SQL information, including the IP address. All right. So I can get into the SQL, I can get into the IP address and so forth, and I can take action on that activity. All right. So that's a quick look at proactive monitoring for JDBC connections and SQL directly through our interface. One other thing we can do also is we can drill into our short-term graph, and we can see at any point, any 30-second instance, those jobs that are consuming the most CPU, the most IO, and the most CPU due to SQL. All right, and we can maneuver up and down, meaning forwards and backwards in time to see what jobs those were. And if the job is still active again, we can work with those jobs. All right, Ash, I'm going to turn it back over to you.
Fantastic, Chuck. And I have to say that tool is probably the fastest tool I've ever used in my whole time in IT. I don't know how they've done it, but it's absolutely like lightning. DB2 for iServices. So what are they? Well, it's amazing to think that DB2 for iServices have been around for 10 years. I don't know where that time goes, but we're going to spend a few minutes now looking at what they are, how you go about getting them, what kind of things they can do, and then finally, how best to run them. So what are they? Well, I like to think of them as a modern alternative to APIs, and they can be used to extract a multitude of information from IBM, and that information can help you monitor, manage, and in some cases, even secure your box. Now, you're all used to 5250 command line interface, ACS, which Chuck has just been using, even administration, runtime expert, and APIs. Well, DB2 for iServices is another for your kit bag, really. They also help the IBM feel like a normal system, as SQL is a standard method, irrespective of platform. And the thing that I like, unlike APIs, there's no need for any programming expertise. So they were, as I say, they were introduced, I think it was April 2010 with V7R1. And just some examples as to what you can do. You can find out which jobs have the largest QTemp libraries. Might be useful in Chuck's example that he just gave. maybe which users haven't signed on for more than 30 days. And I know you can do this from a command line. You can do it from OpsNav. But hey, it's a modern interface. You can also see the biggest library on your machine really, really quickly. And in addition, you can see if it's been saved cleanly. You can show how much storage is being consumed by users on the system. And remember, the maximum storage allowed is set up on the creation of the user profile. That might have been years ago you created some of these profiles, and it defaults to no max. So it's always worth keeping an eye on that. You can also see if you're having any users with maybe excessive sign-on attempts, often an indicator that somebody's trying to get onto your machine when maybe they shouldn't. These are frequently added to, and in the last technology refresh, there are a total of 28 that were either added or enhanced. So I think they're great, but where can you find them? Well, you can simply go to the link displayed in that first bullet. But in all intents and purposes, you've probably got them already. They're delivered via the DB2 for I group PTF. So for 7.4, that's SF 99704, 7.3 99703, and 99702 for 7.2. And IBM are very committed to them. With every new release, more get added or enhanced. If you launch ACS and select Run SQL Scripts, as Chuck did a little bit earlier, insert a number of rows into that table, you'll have the ability to see them. And rather than write a script from scratch, as you'll see shortly, you can insert from examples before customizing it to suit your needs. So that's how you find them. How can you run them? Well, for those of you that prefer the green screen, and I know there are some of us still that do that, you can simply do a str_sql and then do that directly. But the real power behind DB2 for I services is when you run them from Access Client Solutions or ACS, like in this example. Something that was announced, I think it was last month, in version 1.1.85 is Content Assist. This helps those that are not overly familiar with SQL to almost become overnight experts. And ACS will steer you by showing you what options are available to you in terms of SQL commands, or if your cursor is in the right position, column select from whatever table you've chosen. And you can just use Control and Enter to toggle between assist on or assist off. You can also save commonly used ones and any customization you've done so that it's ready to run quickly next time. And as you'll see shortly, Robot Monitor builds upon this by allowing you to automate the regular interval-based running of these SQL scripts and then doing something with the results that are returned. In the example we see here on the right, we're pulling in a number of fields from a service called QSys2.asp_info. So let's take a little look in here. We've opted to simplify that script, and all we're interested in here, we just want to see the capacity that ASP1 provides. And I'm now going to hand over to Chuck, and he's going to demonstrate how you can add some automated value to running these SQL commands in Robot Monitor. Chuck, back over to you.
Thanks, Ash. We've discussed these quite a bit in our local user group and so forth. And so exploiting these inside of Robot Monitor is actually quite easy. All right, so these are all the various monitor types that I've got set up in my instance of Robot Monitor. And at the very bottom here, you'll see something called user supplied decimal, integer, percentage, or text. So what you can do is you can define your own data collection based on your own SQL statements. So they can be custom SQL statements that look at your application, or they could be utilizing the IBM services. So for instance, here we have one called number of enabled users that have all object. All right, well that's interesting. Hopefully that's a very small number. You might be shocked what's on my system. let's take a look at that. So I've enabled a number of these, and so for instance, here's the number of all object users on my system, so airing my dirty laundry here in public. Let's just take a look at how this is set up. So my data collection says this is a user supplied integer data collection. I'm looking at 2 of my systems. My collection frequency is 10, so every 10th 30-second iteration, I'm collecting this data. And in this case, I'm looking at the IBM service where we're looking at the QSys2 and user info data, and specifically looking at all object users. All right, so now what's happening is Robot Monitor is collecting this information in real time, and we have thresholds set up. So I set up a threshold of 5, and I'm being notified through a message in the message queue that we've exceeded our maximum number of all object users, obviously by a little bit. Other things that I've got set up here, for instance, number of connections to a particular IP address, so or from a particular IP address. All right, so in this case, I've got 8 connections. All right, and my data collection looks like this. In this case, I'm looking at the QSys2 NetSat job info. All right. So where did I get all that information, and how did I get that then embedded into Robot Monitor? Well, here inside of ACS run SQL script under edit is insert from examples. And these are a lot of fun to play with. All right, so here's IBM services, and you'll see that they're broken up into different categories. For instance, communication, NetStat, Java is represented here. PTFs, these are used common, or it's a common usage to look at your PTFs and compare them with what's available. Here's the security related services and spool file related services. All right.
I really like these, Chuck. It really takes the thinking out of it, doesn't it?
Exactly. Yep. And so for instance, I could say something like where username equals Chuck. All right. And if I insert that, now that's inserted into my script area. And when I run that, all right, so it's out there collecting that information. How much spool storage is my user profile taking? All right, so that could easily be embedded into a Robot Monitor to look for certain service profiles on your system that are using spool storage, and there you go. All right.
That's incredibly quick. When you consider what that's had to do in the background, Chuck, if you were to do that manually, how long would that take you on the green screen?
It would take me a while. Absolutely.
Yes. Yeah.
If I would do it at all, and I probably wouldn't. Right.
That's fantastic. So let's have a little look here. We've got quite a few questions actually. Somebody has asked, which I can probably grab this one. Are there any services for Power HA or Power HA statuses? And there are. There were some, and I think they were added to in June, and they allow you to establish the status of cluster services, the admin domain services, and the cluster resource group. So you can establish various statistics around there. One here for you, Chuck. Can Robot take an action on an offending job? So if maybe a threshold is hit, can you do something with that job?
Yeah, that's a great question. Robot Monitor is not just a monitoring tool. It does have the ability to take an offending job like an incoming JDBC request, and it can automatically up the run priority, let's say from an incoming of 20, and it can iteratively up it to all the way to 99, thereby throttling it back. It could even put it on hold if you wanted to, and then it would release it when CPU is under control.
Excellent. I mean, that would be such a great help. And if you were to dovetail that with, Robot Alert, you'd have an email, it would come and tap you on the shoulder. You'd have changed the priority of the job or held the job, and you can go and investigate it. Again, it takes the thinking out of it, which is what I like. So Chuck has launched the second and final poll question. So if you could just tick whichever you think is relevant here. myself, Chuck, and some of the other guys, we conduct a number of technical updates throughout the year. So if you'd like to hear about what we've been doing and we can hear about what you've been doing, please tick the tech update box. If you'd like a demo of Robot Monitor, we've done it very, very quickly today. That's something we can organize. If you'd like to take a trial of Robot Monitor, and remember, trials are typically 30 days and come with full technical support during that time, choose that. Or if you'd like to know more about implementation services that the services team at Help Systems embark on, click away there.
Awesome. All right, we'll leave that open for a moment. We'd like to thank everybody for attending today's presentation. I know it was a quick 30 minutes, Ash, but thank you for joining me to talk about the two faces of SQL.
No problem, it's been good. And for those questions that we haven't answered, myself and Chuck will take those offline and we'll answer them directly. We should have probably made it a little bit longer webinar, Chuck.
I think we could make this quite a long webinar, and you know, SQL on IBMI is quite the topic.
Yeah.
Yeah.
Fantastic.
All right. Thanks, Ash.
Wonderful. So just to finish off, so Help Systems is it's a one-stop shop for anything IBMI related, from backup and high availability with Robot Save and Robot H3, Robot HA, through integrated doc management, security to monitoring, as demonstrated by Chuck today, and of course, alerting, or maybe extracting data out of the eye into a modern interface with business intelligence. There's also capacity planning with zero overhead using Performance Navigator, right the way through to the ever popular Robot Schedule for advanced automation. And that's all we've got time for today. So that just leaves me to say thank you for your time, and thank you, Chuck, for your demonstration. Have a great day.
Bye-bye.